All right, geometry, welcome back. Today we are talking about the Ohio State Test reference sheet. So this is the reference sheet that you will receive on your geometry state test on Thursday and Friday of this week. We're going to go through some of the pieces of it today, look at some of what it offers, what it has, look at the things that aren't on there, and sort of help get you familiar with it so you can use it to the best of your ability on when you take that test. So the first thing you see is a bunch of conversions. So this top part over here is just conversions, like 1 foot is 12 inches, 1 yard is 3 feet, and all these. So we have distance conversions are on this side. So this is distance. So these are all your lengths, like 1 meter to 39.37 inches. And then this is weight is our middle conversion. Or mass, I guess you could say. 1 pound is 16 ounces, 1 pound is 0.45 kilograms, 1 kilogram is 2.2 pounds. So you have all those conversions. And then we have, this is liquids, like liquid size, essentially. So 1 cup is 8 fluid ounces, 1 pint is 2 cups, so on and so forth. 1 liter is 1,000 cubic centimeters. So anytime, most of the time, they don't have you do conversions too frequently, but anytime that you do need to use conversions, you can use these pieces up here to help you. So all you have to do is, if I have however many meters, I just need to multiply that by 39.37, and that'll get me to my inches. Or if I need to go from inches to centimeters, I can take my number of inches, I can multiply by 2.54, and then I'll get my number of centimeters. Now, right below that on the front of our reference sheet, because it is two-sided, on the front of our reference sheet, we have our trigonometry stuff. So this is good. So all that stuff we learned in our, most of the stuff we learned in our trigonometry unit is all on here. So we have our sine, cosine, and tangent. These are our trig ratios. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that SOHCAHTOA that we talked about, that is actually sort of splayed out for you on this thing. We still need to remember when to use these, though. Remember, so anytime you're solving for a missing side or a missing angle of a right triangle, we can use those trigonometries. But in order to solve for a missing angle, we need to use those inverses, like inverse sine, inverse cosine, inverse tangent. But if you're solving for a missing side length, and we have some pieces, then we can use those to solve for our opposite side, hypotenuse, adjacent side, whatever, based off whatever that angle is. Our trigonometry also continues with our special right triangles. We learned about 2 types of special right triangles, our 45-45-90 triangle and our 30-60-90 triangle. Now remember, our 45-45-90 triangle had x's being the same, and then our hypotenuse was x times radical 2, so it could be like 3 radical 2, 4 radical 2, so that is shown for you. Our 30-60-90 triangle was the other one that was the same. And so that was like our tree, 2 tree, tree root 3 was sort of like the pattern. So x, 2 times x times radical 3. So it could be like 4, 2 times 4 is 8, and then 4 times radical 3 would they be that bottom. So it's important for us to be able to recognize when do we have 45-45-90 triangles and 30-60-90 triangles. Use these patterns to help you figure out what are those missing sides based off where those angles are and what those sides are. So you have those shown to you as well. If we flip over our reference sheet to the back side, you got a lot more stuff over here. So this is our area formulas. So these 3 pieces are area. Oh, that's the wrong button. So if you want to find the area of a triangle, its area equals 1/2 b times h. Now it has a little key up here to tell you. So b represents the base and h represents the height. So that's our bottom of our triangle times the height of the triangle from the base to the top of the triangle. But they always need to be perpendicular to each other. Our parallelograms. Now, once again, parallelograms represent squares, rectangles, rhombuses, all those things. It's always just base times height. So whatever one side is times the height of that triangle or times the height of that shape will give you the area of that parallelogram. And then our circle, we have 2 pieces of information from our circle. So the area of our circle that we used with our sector area was pi times radius squared. So that's how we did our sector area. We did angle divided by 360 to get the portion of our circle, and then we multiplied it by the area to figure out how much of that total portion we had. And our circumference was the part we used with arc length, 2 times pi times radius. That's your length around the circle. So the length around the circle versus the length inside the circle, our area versus our circumference. Now, we use circumference with our arc length. So whenever we only had to find a piece of that, we just did angle divided by 360 times 2 times pi times the radius, and that gave you that little portion of your arc length. On the other half, we have volume over here. So volume is the unit that we didn't quite really get time to spend on, but luckily you've worked with volume in the past in your middle school math classes. So the volume of prisms. So once again, your prism is like your 3D rectangular shaped 3D triangular prism. It's like a box. It's capital B times H. Now, capital B stands for the area of the base. So you have to think, okay, what type of shape is the bottom of my prism? So if it's a parallelogram, like a rectangle, you use the parallelogram area formula. If it's a triangle, we have to use the triangle area formula. If it's a circle, we use the circular area formula. So you find the area of the base, and then you multiply it by the height. Our cylinder is really just a circular prism. It's the area of the base times the height. Our sphere is 4/3 pi times radius cubed. Our cone formula is 1/3 pi times radius squared times height. And pyramid is 1/3 the base. So once again, for a pyramid, depending on what type of base the pyramid is, whether it's a square pyramid or whether it's a rectangular pyramid or triangular pyramid, you have to figure out what is the base of that shape first, and then you're going to do 1/3 times the base, or times the area of the base times the height. And that is our volume. So you have all those volume formulas. So whenever you're trying to find the volume of a shape, use this reference sheet. Figure out what type of shape it is. We'll get the reference sheet, use that to help you. And then we have a few other formulas here at the bottom. Our distance formula, this was the very first formula we talked about this year. Once again, this is derived from your Pythagorean theorem. It's like your a squared plus b squared equals c squared. If we solve that, using our distance formula, we get this. So the distance between 2 points, it always worked for 2 points, was the square root of parentheses x2, so the second x coordinate minus the first x coordinate squared, plus the second y coordinate minus the first y coordinate. That was our distance formula. Once again, you can still use the Pythagorean theorem by creating that triangle, if that's the way you prefer, but that distance formula is there as well that we talked about at the beginning of the year. Our quadratic formula, this is probably like the one thing on this reference sheet that's actually related to Algebra 1 and not related to geometry. So you probably don't need to use the quadratic formula. If for whatever random case they do have you solving for a quadratic where you have like x squared plus 4x minus 3 equals 0, and you have to solve for x, anytime you have a trinomial like this, we can use that quadratic formula. Remember, we're looking for a, b, and c. We learned this last year. So a is the number in front of your x squared. So in this case, it'd be 1. B is the number in front of your x, which in this case would be 4. And then c would be your last number that doesn't have an x, which is -3. And then we take those numbers, plug it in for a, b, and c in this formula. Then you could type that whole thing into your calculator, and you would be done from there. And the last piece on here is the general addition rule that we talked about just last week. Our addition rule was for probability. So the probability of A or B, the probability of an OR event, was always equal to the probability of the first event plus the probability of the second minus the probability of A and B, the intersection of the two. So the union of two events, the probability of A or B, probability of either of them happening is equal to the first probability plus the second probability minus the intersection, the and, having both of them happen at the same time. And this is your general reference sheet that you receive on your state test. The other thing I'm going to show you really quickly is your calculator. So once again, this is the calculator. If it probably looks familiar to you because it's the Desmos graphing calculator. There are some things that are slightly tweaked, so it's not exactly the same as what it should be. But for the majority of situations, it's going to work exactly the same. So you can still type, you can still graph, you can still do all those things on here. Probably the biggest thing I want to remind you is that in this function section right here, under the functions, you have sine, cosine, tangent, and inverse sine, inverse cosine, inverse tangent. So those triggers, once again, that are on that reference sheet, you have all of them right here. So whenever you need to calculate the sine of an angle, so sine of 45, let's say, oh, that's 445, sorry. Sine of 44, we'll say, we have it as 0.694. So you can use that, or 0.695 if we round. We can use that then to use that to calculate our missing sides whenever we're trying to use those trig ratios. You have your squared button right here in case you need to square something for whatever reason, like the Pythagorean theorem or other things. Your pi is on here, your square root button. So you have all those things that we've been using before in case you need to do anything else. And once again, you can graph on here. You do not need to change it into degrees. It will automatically start in degrees because this is the state test calculator, right? So you don't have to worry about bouncing from degrees and radians. Just try to keep it in degrees, and it should start like that. Other than that, that's your reference sheet in your state test calculator. Let me know if you have any questions or you want me to go over any of this again with you. I will gladly show you some more pieces to it if you have any questions. But that is where we will stop for now.